Okay, welcome to Chapter 4, Section 3, Writing Functions. We're talking about example number 2 when we're going to read an example. So everything's going to be given to you using words. Here's the other two if you want to. There's that one, and there's that one. Okay, on the second sheet of paper. All right? These are going to be given to you as words, as a sentence that's going to describe it. And we got to look into this and figure out what's actually happening. And in the next example, we're going to take this information and see if we can write an algebraic function for it. Right? So we're going to take one step at a time. In this case, we need to identify the independent and dependent variables. So let's look at this example. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. All right. Now, again, if we were in class, we would start debating this statement. All right. Some people could say, well, in the summer, when the temperature rises, okay, we're not talking the summer though, we're talking winter. But when the temperature rises in the summer, maybe the air conditioner kicks on. That's not what they're talking about. In the winter, more electricity is used when the temperature goes down, all right? Which probably means that, more people are inside, more people are, huddling up in front of TVs and Netflix. A lot of furnaces run on gas, but maybe there's electric heaters going on, right? We're not really debating the truthfulness of this statement. That's where I think we get hung up with if we were actually in class. For this problem, we're just trying to find the independent and dependent variables. So what we're going to look for, two things that are in this story, or I call it, it's not really a story, there's no plot, but this situation, two things that are measured. Now, when I measure something, a lot of people think, okay, you're going to measure something. Here, I'm on my desk. There's a ruler. Okay, you can measure length. But there's other things that can be measured. You can measure weight. You can measure area. You can measure volume. You can measure speed. You can measure capacity. There's a whole bunch of different measurements that we have in science and physics. Two measurements that are happening here, one of them is pretty obvious. We've got temperature, and you can measure the temperature. As a matter of fact, most people, they wake up and they listen to the news to find out how cold or warm it's going to be. And by the way, I'm not concerned about whether I'm measuring temperature on Fahrenheit or Celsius. The units that you measure are not really relevant right now. It's the fact that you're measuring temperature, okay? And the other thing that we're measuring in this one is, it says more electricity is used. Well, what do you mean by more electricity? Well, that's a measure of how much power that your household is using, or business office, or whatever it is we're talking about. So the other thing that's being measured in here is the amount of electrical power. Now, again, I'm making this video, so that's why I'm writing it that way. But if you were doing this on your own, you could just say electricity. All right. Well, how do you measure electricity? A lot of you who live in homes or apartments, you might see there's a meter, an electrical meter that's outside your house. Most of that is done automatically now, but there used to be a time where the power companies would have to send the person out, walk house to house, and read the meter to find out how much electricity that your house has used, and then that's what they would send for the bill. All right. So with the data process stuff that we have now, keeping track of all that electronically, I don't think anyone's ever seen it, but I have a meter outside my house. So this is it's a way of, and we're not going to get into the physics of watts or whatever it is that we're measuring here. Okay, so now that we've identified what the two things are that we're measuring, which one causes the other one? Okay, so we're looking for cause. All right, and what does that mean when I say cause? So I mentioned early, like the first week, that algebra is the study of how something that we measure affects something else that we measure. All right, so we've got two things that we're measuring. Which one affects the other one, and which one causes the other one to change? So I'm going to do it backwards first, and let's see if this makes sense. So if a house, one house, decides that they're going to like turn on all their appliances and increase their electrical power, all right, it says more electricity is used when the temperature goes down. Is that going to make the temperature go down? Does the outside world look at this and say, all right, so the Johnsons on Sumner Avenue are saying they're using a lot of electricity, so the temperature in St. Paul overall is going to go down? Well, that doesn't make sense. The amount of electric power that a house uses or a business uses does not change the outside temperature. And I know we're going to avoid a discussion about global warming, all right, for right now. But does it make sense that if the temperature goes down, that more people are going inside and using electronic devices? You know, according to this, it says more electricity is used when the temperature goes down. So that seems to make me think that, like, when it gets colder in the winter, like brr, okay, that this statement is saying more electricity is used. So it seems that the temperature is causing the amount of electrical power to change. So if that's the case, then this one is the independent variable, and this one is the dependent variable. And let's think about this. Does the amount of electrical power depend on the temperature? And according to the way it's written here, and again, I don't want to get into whether that statement is true. I'm just going by what they gave me. According to what it's given, more electricity is used when the temperature goes down and less is used when the temperature rises. It seems like the temperature is, the temperature is actually kind of like not in any one person's control. So that would be independent. And how much electrical power you're going to be using, first you figure out what the temperature is, and then you're going to, decide whether you're going to stay home or go, whatever. Okay? Let's do another example, or two actually. Two more. All right. So maybe you are sending some, like a care package of, I don't know, cookies and other things to, like, your grandma or your grandpa or someone. And you go to, not to single any place out, maybe you go to the post office or UPS store or FedEx or someplace like that. If you have like a little box, like maybe a dozen cookies or something, it's going to cost some money to send that. But if you have a bigger box, it's probably going to cost a different amount of money, probably more. That's not part of this problem. How much it is not part of the problem. That's in the next video. But one of the things, like when I say we, I mean either me or my wife, when we've gone to the UPS store or the post office to mail something or to ship something, like a package, my wife has sent gifts to her cousins and stuff. First thing they do is they drop it on a scale. And then using the scale, it falls within some sort of category for how much we have to pay. All right? So I'm describing the situation. Now let's figure out what are the two measurements here. Well, this one a little bit easier than the last one. Okay, we've got cost and weight. And when we say cost, the cost of the actual shipping the package. All right. Occasionally I'll order something from Amazon and it's free shipping, which is nice, but there's a business out of Chicago where they sell like science fiction models. I build models, and the guy who runs it, like when you put in an order, he'll get back and he'll email what the shipping is, because he takes the box to the post office and they tell him how much the shipping is. Okay, so which of these do you have to know first before you find out the other one? Which of them causes the other one to happen? Well, it seems like first you have to figure out the weight of the package, and then the company that you are working with is going to tell you how much that's going to cost. So this is the independent variable, and this is the dependent variable. And let's try to phrase it this way to see if this makes sense. Does the cost of a package that you're going to ship depend on, because it's dependent, how much the package weighs? So, extreme example, if I am going to ship a package that has like, I don't know, that marker in it, you know, I'll get like a small box or something and say, hey, I'm going to ship this Sharpie to my friend in California. I don't know why I'd do that, it was just on my desk. Compared to shipping, say, like a refrigerator, it's probably going to cost more to ship a refrigerator than it will the marker. So the weight of the package is independent. That really is based upon, you know, how big the thing is that you're going to ship, and the cost depends on how big it is. Okay? One more, and I know that this is complicated. I wish we were in class together so we could, you guys could like sound this out and talk it over with each other. The faster Ron walks, the quicker he gets home. So the two things that are being measured here would be Ron's speed, whether he's like walking really, really slow, kind of dragging a little bit, or whether he's like, you know, walking with a little bit of a clip because he wants to get home to, you know, watch his favorite show. And the other thing that's being measured is Ron's time. And when I say time, we mean like how long it takes in minutes, hopefully not hours, but how long it takes in probably minutes for him to get home from wherever he's at, from school or work or wherever it is. Okay? Which of those does Ron get to choose? Which of those actually mean is what Ron's doing to control the situation? Well, Ron's choosing how fast he walks. And because he's choosing how fast he walks, it's going to affect his time. If Ron, and again, this is getting into the next example, but it's good to talk about it now. If Ron decides to walk a little bit faster, his time to get home is going to go down. And if Ron decides he's going to take a long time, his time is going to increase. All right? So Ron's speed is the independent variable, and Ron's time is the dependent variable. And it makes sense that Ron's time, how long it takes for him to get home, depends, excuse me, I'm almost caught myself. Let me start over. How long it takes Ron to get home depends on how fast Ron decides to walk. So that's the dependent relationship. This depends on that. All right, we will do, we'll see this independent, dependent stuff in the next video, but in that case, we're going to actually put some numbers with it.